So as I mentioned in the commentary here, sometimes certain math problems don't just have a single answer, right? They might have an infinite amount of answers or a range of answers. So inequalities are an example of that. So that would be greater than is your greater than symbol, right? That would be greater than or equal to, greater than or equal to. For example, 7 is greater than 3. That's true. 7 is also greater than or equal to 3. That's true. 7 is also greater than or equal to 7. That's true also, right? 7 is greater than or equal to because it can be or equal to. Is 7 greater than 7? And you would say false, right? So less than, there's our less than, equivalently less than or equal to. All right. We're going to talk about these solutions, or I'm sorry, the graphs of these. For example, let's do it with this first one here. Write an inequality involving the variable x that describes the set of numbers graph below. So do you notice at the -4 it's open? That means it does not include it, and then it's everything to the right. So we say x is greater than, because it's got to be above, not including the -4, greater than -4. Now this second one has the 2, it's filled in. I don't know if you can kind of see that. It's filled in and then it's going left. So it includes the 2. So we want everything less than 2, but we want to include the 2. So we're going to say less than or equal to, right? The third one here has x is less than 5. It's open at 5 and it's going to the left. We're less than 5, right? I'm gonna hold on here just a sec. All right, so we had x is less than 5 on this. Now let's go ahead and take the actual inequality and put that thing in interval notation as well on that. And you know what? Before I do that, let me go back to this x is less than 5 and let's put this in interval notation. Interval notation is reading it left to right. So if you notice, all of this is solution up until 5. So you write that as coming from negative infinity up to 5, and you put a parenthesis around the 5, meaning not including the 5. In fact, let me do this one that we had before, the x is less than or equal to 2. So it's all these solutions up to 2, and we include the 2 as well. So we write that from negative infinity up to 2, bracket, meaning I'm including. The parentheses, negative infinity and positive infinity, they always have a parenthesis. They're not a number that you arrive at. This other one that we had where we had x is greater than -4, so we were not including -4. So we're starting at -4, going left to right, and up to infinity. Starting at -4, going up to infinity. That's some interval notation for those ones. So let's go ahead and do this one. Let's do the graph first. Greater than or equal to -5. Greater than or equal to. So we're going to have that filled in, and we're going to pointing to the right, greater than or equal to. So the interval notation will be a bracket, meaning we're including the -5, and then it shoots up to infinity. So there's the graph on the left, interval notation on the right. Let's do this next one. X is less than 2. So strictly less than, don't include the 2, so open hole on the 2. X is less than 2, there's our graph. And our interval notation, meaning it's coming from negative infinity up until it hits 2, but I do not include 2. There's our interval notation. Again, the parenthesis on the 2 means we do not include the 2. Why don't you guys do this one on the Jamboard? Check your work on that with the graph that's filled in, and it's all solutions from negative infinity up to -1, including -1. All right, how about this compound inequality? -4, and how you actually say this, this is how you read this. X is less than or equal to 3, and And then you read this one, but you don't read it this way. You got to flip it around and say it that way. X is greater than negative 4. So x is less than or equal to 3. And, so let's graph this. I'm less than or equal to 3, so here's that part. And I have to be both. I have to satisfy both. And I'm greater than negative 4. Let's do that one. I'm greater than negative 4. Now it has to be both. So the solutions are everything in between. So here's the actual graph over here in red from negative 4, not including negative 4, up until 3, and you're including 3. And then our interval notation will be from negative 4, reading it left to right. Do not include negative 4, but include all the solutions up until 3. Okay, let's do this one together with the 2. So we read it, x is less than 6, and then we read this part the other way around. X is greater than or equal to 2. So we're less than 6. Here's our less than 6, and we're greater than or equal to 2. Greater than or equal to 2. And it has to be both. And means both. So there's their solution in between. Less than 6, greater than or equal to 2. Let's put it over here. Less than 6, greater than or equal to 2. So we're right between them. Bracket on the 2 up until 6 with a parenthesis. And now let's go ahead and solve some inequalities. Let's just solve for x. Remember the rules when you're solving inequalities. If you multiply or divide either side by a negative, make sure you switch what's called the sense of the inequality. It doesn't apply in this scenario. You have x is greater than or equal to negative 11 plus 7, negative 4. X is greater than or equal to negative 4, greater than or equal to. So there's our graph. Interval notation would be from negative 4 on. But it does apply here, negative 5x greater than or equal to 35. In order to solve this, we'd have to divide both sides by a negative. Again, if you multiply or divide both sides by a negative, you gotta switch that sense of the inequality. Otherwise, you'll end up with the wrong solution set. So our solution set is less than or equal to negative 7. Right, so it's saying 7 or less is a solution. Well, if I hadn't switched it, it would have said these are solutions, like including like 0, right? Well, 0 is not a solution, because 0, if I plug 0 in, 0 is not greater than or equal to 35. So if I hadn't switched the sense of the inequality, if I hadn't flipped it when I divided by a negative, I would have had the wrong solution set. Well, in interval notation, this is negative infinity up to negative 7 with a bracket. All right, let's go ahead and do this one. Divide by, well, now we're dividing by a positive, so it doesn't switch the sense. It stays the same. So x is greater than negative 6. I'm greater than negative 6. Negative 6, whoops. Negative 6 with a parenthesis on. All right. Well, you guys try that. There's your solution and your graph on that. You divide by negative 2. Make sure you switch the sense of the inequality, the way it is, the direction of it. And let's move on. Now we've got a whole bunch of mess, so we're going to have to gather all our, just like when we're solving linear equations, we're going to have to get all your x's on one side. And if you have like terms, you can combine like terms first. Negative x plus 19x, you got 18x. Plus 45 less than or equal to, over here I got negative 17 plus 8, so negative 9 plus 12x. Now I'm going to get all my x's on the left, so I'm going to subtract the 12x. So I got 6x plus 45 less than or equal to negative 9. Now I'm going to subtract the 45. So I got 6x less than or equal to, what's that, negative 54. And finally, I got to divide by 6. Well, that's a positive 6, so there's no issues here. I keep that the same direction, the sense of the inequality. 54 divided by 6, what's that, 9? So I got less than or equal to negative 9. There's our graph and our interval notation for that. Let's keep going here. Now I got to distribute that. So I got 11 minus x minus 5. I can combine 11 minus 5, so I got 6. I want all my x's on the left, so I read this properly. So I have 6. 13 minus 1 is a 12x, less greater than or equal to 6. Get all the numbers on the other side. So now I got 12x greater than or equal to 0 divided by 12. It's a positive number, so it's still greater than or equal to 0 divided by anything 0. So x is greater than or equal to 0. And our interval would be from 0 on to infinity. Include the 0. Any questions so far? Go ahead, distribute that, distribute that. Combine any like terms on the same side. Get all your variables on the left. Divide by, now notice I'm dividing by a negative here. So don't forget, you got to switch that sense. Greater than, right? Switch that sense. So x is greater than negative 4. Greater than negative 4. So negative 4 on. There's our graph and our interval notation. All right, why don't you guys try this one? Well, check yourself with that problem. Make sure you did that right. Make sure when you divided by that negative 5, you switch the sense of the inequality there. And then let's move on. You can pause that if you need to. But let's move on here to one with some fractions, everybody's friend. You know what I would do is I would multiply by the least common multiple of 2 and 4. Their least common multiple is 4. It's kind of like if I was adding 1/2 plus 1/4, right? I'd have to get a common denominator of 4. So I'm going to multiply both sides by 4. And then I can clear out the fraction. I don't have to deal with the fraction. So 4x over 2, that's a 2x. And then minus 20 over 2 is minus 10. Over here, when I distribute that, I got 4x over 4, that's a 1x. And then 4 times 1 is a 4. And now this is all I'm solving, right? I don't have to deal with fractions any longer. So I have x minus 10 less than or equal to 4. Add 10 to both sides. X is less than or equal to 14. So here's our 14 less than or equal to. That's filled in. Got a bracket on that. All right, similarly for this one, go ahead and pause that and try. And there's our solution for that one. You guys, x is less than negative 16. Again, you got to switch the sense of that inequality with the way that I solve that. One more, and then we'll get into compound inequalities here. Three minus 20 negative 17 plus 2 negative 15x. That's minus 24 on this side, greater than 5x minus 5. Now I'm going to subtract the 5x. So I have Oh, I'm sorry. Good grief. I messed that up. Hold on, let me erase. Oh, gosh. My bad. 3x minus 24 minus 20 plus 2x. Sorry about that. That changes things. So we have we have 3x plus 2x is 5x minus 24 minus 20 is minus 44. My apologies. Subtract 5x. Now notice what happens here. I have 0x minus 44 is greater than negative 5. Now the question is negative 44 greater than negative 5? You know, you have negative 5 here, you got negative 44 way down here. Negative 44 is not greater than negative 5. This is false. Well, if you get a false statement, you know, you're just left with numbers here, and you say, is it true or false? If it's false, there's no solution here. If it would have been something true, like let's say we get to the end and it had like 7 is greater than 2, that's true. That means anything. That would have been infinitely many solutions. That means any x variable will make it true, right? But that's not the case with this one. So variables cancel. Determine if it's true or false. If it's true, it's infinitely many solutions. If it's false, there's no solution. All right, let's get into compound inequalities here. X is less than or equal to 7, and both of these have to be true. So I like to graph it. Less than or equal to 7 is this. Greater than negative 4. Here's my greater than negative 4. And both have to be true. In other words, where's their intersection at? So our solution set will be from negative 4, not including negative 4, up to 7, including 7. In interval notation, that'll be negative 4, parenthesis, up to 7, bracket. If you want to put them together, it's less than or equal to 7, greater than negative 4. Okay, that's your set notation on the bottom. Now, or just means one or the other has to be true. So 6x plus 1 less than or equal to 7. Or, now I'm going to solve this one separately. Subtract 1, divide by 6. So x is less than or equal to 1 has to be true, or add 7, divide by 3. So I got to be less than or equal to 1, or greater than or equal to 6. So here's my graph. One or the other has to be true, not both. Notice these do not intersect anyways. So it's just one or the other has to be true. So when you write your interval notation, you can say from negative infinity up to 1, or, so we're going to put a union on there, and then you go from 6 on. That's union, that's for or. Okay, so there's our solutions.
Is that a U or like a V?
Yes.
Like
good.
if we were to write it.
That's a capital U. Yeah, big old capital U. Union.
Okay, thank you.
You bet. All right, for these next ones, go ahead and try those. Go ahead and check your work on that and scenario, meaning both have to be true. That would be great. X is less than 7 and x is greater than 4 with our graph down here. Thanks for watching.